Now we're going to look at the metric measure for mass. You may think of it as weight, but in science we call it mass. The base unit for the measurement of mass in the metric system is the gram, abbreviation G. There it is in our table. We have the kilogram, the megagram, which by the way is the same as a tonne, so I'll write that in there. The other engineering prefixes we have are the milligram and the microgram. So to do our conversions now, from right to left along the top and multiplying across the top, and each one of these is multiplied by 1,000 or 10 to the power 3. So if you have a look at the gram, we have 1,000 grams in a kilogram, but 1,000,000 grams in a megagram or a tonne. Going in the reverse direction, from left to right, it's divide by the same quantity. So divide by 10 to the power 3 for each of these conversions. But dividing by, and let's make that last one a divide, so I've made a mistake. Oh, there it is. Now dividing by a positive power, that is a base with a positive power, is the same as multiplying by the negative power. Now if you have a look at the second index law, that's really what the second index law is telling you. It's telling you that if you've got 1 over 10 to the power m, so you're dividing by 10 to the power m, that is the same as 10 to the power negative m. So that's an abbreviated form of the second index law. And we're going to be using that one quite a lot. So our first conversion here is 6.1 kilograms to grams. So kilograms to grams is in that direction, so multiply by 10 to the power 3. Now that's the answer in scientific notation. To convert that to a conventional number, we'll have the 6.1. We now need to move the decimal place 1, 2, 3 places because we're multiplying by 1,000. So it goes from that position to that position, and what hasn't got a digit in it becomes a 0, and that is now grams. So 6.1 by 10 to the power 3 grams in scientific notation, 6,100 grams as a conventional number. Now the next one is 5.85 by 10 to the 8 micrograms to kilograms. 5.85 by 10 to the 8. We're converting from a small unit of measure, micrograms, to kilograms, so that means we need to divide. So we're dividing by 10 to the power 3 to convert from micro to milli, by 10 to the power 3 from milli to grams, and then from grams to kilograms, divide by 10 to the power 3 again. So using our index laws now and simplifying the denominator, so that it becomes, adding all the powers in the denominator, we've got in total divide by 10 to the power 9. Using the second index law now, 5.85 multiplied by 10 to the power 8. Now this power of 9 in the denominator comes up to the numerator and becomes negative, so hence 10 to the power 8 take away 9, which is 5.85 by 10 to the power negative 1, and that's now kilograms. Now if we want to write that as a conventional number, it becomes 5.85 multiplied by 10 to the power negative 1 is the same as divide by 10, so it becomes 0.585, and that's, remember, kilograms. I haven't left myself very much room to do the next one. So let's now choose a different colour for this one. We want to convert 500 grams to tonnes. So 500 can be written in scientific notation as 5 by 10 to the power 2. And to convert from grams to tonnes, we've got to convert from grams to kilograms, so divide by 10 to the power 3, and then from kilograms to tonnes. Tonnes are, remember, megagrams, so it's divide by another 10 to the power 3, so that will be 5 multiplied by 10 to the power 2. Gathering up the powers in the denominator, using the first index law, 3 plus 3 is 6. Now using the second index law to bring up the positive power in the denominator and make it negative. So we've got 5 multiplied by 10 to the power negative 4, and that's now tonnes or megagrams. As a conventional number, it means we need to move the decimal point towards the left now, so 4 places to the left, so it would be 0.0005 megagrams or tonnes. Decimal point moved back from that position, 1, 2, 3, 4 places, so 3 zeros and then the 5. Remember that multiplying by 10 to the power negative 4 is the same as dividing by 10 to the power 4, which is dividing by 10,000. Now our last metric measure is volume, and the base unit is the litre, and these ones are the same in that they use the same prefixes. However, there is another one above the megalitre, a larger unit of measure, which is the gigalitre. I haven't left myself very much room here, so I'll just have a little play with it, see if I can. There we go. So now I should be able to put in the gigalitre, and I'll put it in here in red. because one of the questions does ask for the gigalitre, and that's just included in the same way. Now all of these measures are multiplied by 10 to the power 3 or 1,000, and going from the large unit of measure to the smaller one, and in the opposite direction along the bottom from a smaller unit of measure to a larger one, which is divide by the same quantity, which is the same as multiply by the negative power. Okay, so if you think about it, when we buy our milk from the supermarket, we buy it in litre or 2 litre or 3 litre containers. When we look at the amount of water we use in our homes, it's in kilolitres. When we measure the amount of water that we have in dams or in rivers or in lakes, it's either in megalitres or in gigalitres. We take our medicines in millilitres, and we measure very, very small quantities of volume in microlitres. So our first conversion is converting 200 megalitres to millilitres. So mega to milli, so we're going down in that direction, multiplying by 10 to the power 3 times. So it will become 200 multiplied by 10 to the power 3 by 10 to the power 3 by 10 to the power 3 again, remembering that 200 is actually 2 by 10 to the power 2, 2 multiplied by 10 to the power 2 multiplied by, let's write that because I'm going to write a room as 10 to the power 9, so 2 multiplied by 10 to the power 2 plus 9 is 11, and that's now in millilitres. If I wanted to rewrite that as a conventional number, it would be a 2 with how many zeros? 11 of them. There's 5, 6, 7, 8, 9, 10, 11 millilitres. Now you can see why we need to use scientific notation, because this is a far more compact way of writing that number. Now in this one I've asked you to give me the volume in gigalitres and in scientific notation, but correct to 2 significant figures. You'll notice that number has got quite a large number of digits. So if I want it correct to 2 significant figures, I want it rounded off in these 2 place values, so it would be rounded up to a 4 and a 6, so it would be rounded to 2 significant figures as 46, and then with all the other place values filled by zeros, like so. So now I've got it rounded off to 2 significant figures, but it's still a very large number. It's 4.6 multiplied by 10, and how many place values do I have when I count them? I want to do this quite quickly, so it's 11, and that's now litres. If I want to convert that to gigalitres, so that's going along the base from the left-hand side to the right-hand side, from a small unit of measure to a large unit of measure. So 4.6 by 10 to the power 11 divide by 10 to the power 3 times. The answer, 4.6 by 10 to the power 2.